Good morning, Leadworks engineers. Today we have another exciting episode of Weekend Workshop, where we discuss the development of Leadworks 5 and associated technologies. Here's a shot I put together, just trying to get an idea of what the lunar surface might look like in Leadworks 5. I'll get to that in a second. Oh, Cyclone, the famous game made in Leadworks 4, actually, but it's available now on Steam on sale this week. I think perhaps for the first time. Cyclone is on sale this week. I'll post a link in the chat and on the video YouTube, but this is a really great game. It's kind of like Portal, but it's got a completely different mechanic. If you like puzzle, action, platformer type things in first-person view, you will love Cyclone. It's really fun. It's very clever too, and it's. I mean, if you like Portal, you'll like this, but it's completely different from Portal. Okay, so last week was a strange week. I was mostly doing administrative tasks. Every once in a while, about maybe once a year, I have to do stuff like this, and that includes taxes. I needed to re-register my entity in the U.S. government system for contracting because I want to do. There's a space project I want to use Leadworks 5 in, which is why I was creating that moonshot. I had to get some contracts in place, write some contracts for our team for the game that we are developing. I had to work out the DLC licensing agreement with an artist that I am working with. Prizes are shipping now. If you are receiving the sticker pack, your prize has been shipped. If you are receiving the Returning Champions prize package, and you are in the U.S., your prize has been shipped. If you are receiving the Returning Champions prize package and you are outside of the U.S., then I still need to find another box to ship these in because I can't do them in the priority mail shipping containers. Well, if I do that, then I'll be paying the flat rate, and they'll cost like $60 each. So I need to get some different like mailer things. Okay, we have a a DLC. The first DLC for Leadworks 5 is on the way. The first-person shooter weapons pack. I'll talk about that in a minute. And Leadworks also appeared in a video from the YouTuber Threat Interactive. Previously, all I've seen from them is just stuff about Unreal Engine. It's them complaining about the performance of Unreal Engine, but as far as I knew, they were still like focused completely on Unreal, so I just never really paid much attention to it. But it looks like their videos are sort of branching out into more general technology now, and they mentioned Leadworks as an example of things done right. We'll take a look at that in a minute too. But first, I have a FPS weapons pack on the way. This is all the view models that you see in first-person view. It's from the same package that our existing automatic rifle comes from, but we have a lot more. We've got pistols. We've got like several automatic weapons. We've got multiple sniper rifles. We've got a grenade launcher. We've got a crossbow. We've even got like some melee weapons and some things you don't even think about. We've got like a fire axe and a flashlight. We've also got a lantern, a candle, a lighter. There's other things in there. Just a lot of variety. A handheld grenade. There's a syringe that you can, like, it just has one animation, but it's just like if you pick up a syringe and inject it into your arm, it's like you're giving yourself first aid, because that's how you heal bullet. That's the treatment for bullet wounds, is you inject yourself with a syringe and the bullet wound goes away. But really good stuff, very good quality, from a very talented artist, and I worked out a deal with them. We're going to do a Kickstarter campaign for this, just to launch this off, and that will help cover the cost of licensing this, as well as it'll take a couple of days for me to convert all of these and set them up. I think the price is going to be $30, and it'll be set up. All the guns will be set up with the default FPS script, and then there's other things that we don't have an existing script for them, so it'll just be the model provided, but it'll work exactly the same as the existing arms that you have. So this will be really great. The quality, I'm very happy with the quality, and there's just a ton of variety. We also have 5 different variations of the arm textures. So you have some stuff that looks like more military, and then you have some stuff that looks more like some survival character. So lots of variety, very good quality, very good animations, and these are really, really hard to come by. These are really hard to find. It's a rare skill to be able to make these and have them look good, so very happy about that. Any questions about the DLC? I think I'll do a Kickstarter campaign, and then I'll probably make it like really short. If I can, I'll probably set it for like 2 weeks. And then we'll be able to get this out to you maybe at the end of the month. And FBX files will be included too, so you can adjust the models or add new animations or whatever you need to do. Okay. Let's take a look at this video. This is going to get really weird. So this channel, Threat Interactive, they made a video about deferred rendering and MSAA, which is something that I've been doing since like 2008, maybe. And it's okay. So there's this weird thing where everybody insists that MSAA is impossible with deferred renderers, and I've been hearing this for almost 20 years. People always say this. And I don't know why, because it's, of all the things you could be confused about, like, MSAA is not a very complex topic. It's a pretty basic... It's like all these really smart people are really confused over it, and I don't understand. I've given up trying to convince people otherwise. I just continue using it, and they continue to tell me that it's impossible. And I'm like, okay, well, I'm just going to use it, and I'm just going to do my thing, and I've given up on trying to convince other people that they're wrong. That was just like one of those things that I put in the category of, well, I'm right and everybody else is wrong, but, good luck ever trying to convince them. And you can watch the video yourself, but let's see if we go up to, he's talking about SSAO.
All comes around, we end up with extremely uncanny edges. If the ambient occlusion composite step is removed before the albedo specular resolve, the edges will then look reasonable outside of color compression artifacts. Even without forced full subsample lighting, these particular edges are temporally stable, because the custom edge detection stencil does recognize these edges properly. We don't need to remove SSAO, as this has been taken care of by modern graphic engineering. Since this video is
very short, it would have been nicer if they showed a screenshot, but
we don't need to remove SSAO, as this has been taken care of by modern.
So this is just something from 2024. And it's just me pointing out, this is probably a reply to a screenshot that I posted. And it's just me pointing out that you can do SSAO on an MSAA texture, and it gives you nice results. So I mean, it's just he's just citing Leadworks as an example of this stuff done right. And then I discussed a little bit. I made a comment on here and talked to a few people a little bit. If I can find my comment.
I didn't delete it.
No, he's been pretty friendly to me, actually. Let's see, I might be... Do I select the most popular or the most recent? Sort by... top comments. Okay. It should be somewhere up in here. Got a lot more upvotes than that. There it is. Okay.
I got your pizza. Hut!
We should.
Here's what I said. I said, thank you for explaining this. We started using deferred rendering with MSAA around 2008 with great results. For nearly 2 decades, people have been telling me that this is impossible, and we just kept on doing it. Here he's still doing it. He's still, but CMAA and SMAA are much better for deferred. MSAA is a headache unless you're using forward rendering. What? Why? Okay, it's not impossible. It's so difficult. Why is it difficult? I seriously don't understand why everybody says this. Oh, it's okay, it's not impossible. It's just really, it's really hard. Really? I don't feel like I have a headache. How is this difficult? Not exactly difficult. It's costly. It's costly. No, it's not. Deferred was never designed with MSAA in mind. Why? I don't understand why this is difficult. You're just rendering to a multi-sample texture. It's very, very simple. And everybody, this isn't a rare, every Reddit, let me show you this. This is so weird. MSAA, deferred rendering, lighting.
Josh, it's just impossible, and you're a god. That's just it.
Many people note that MSAA does not work with deferred shading. Why doesn't it? Let's look at Wikipedia.
Deferred lighting can be used for MSAA on DirectX 9 hardware. Citation needed.
Due to separating lighting stage from geometric stage, hardware anti-aliasing does not produce correct results anymore since interpolated subsamples would result in nonsensical position, normal, and tangent attributes. What? Why would you have that? First of all, this is so... You don't have to do it that way. I promise, if you look this up, everyone will either say that it's impossible, or they will say that... Here's what I need to do. Reddit. Why don't devs use MSAA? It looks better, plus no artifacts. That doesn't make any sense. Because of the deferred rendering possible pipeline, because while it is possible, it is much more performance heavy. No, it's not. It's about the same cost as FXAA. It's so weird. Here we go again. The edge detection alone would be messed up. Why? You're fundamentally going to have to reuse the SMAA edge detection. Even Rockstar Games failed at implementing MSAA in their deferred renderer. Why? These people are smart. Like, oh, here he's telling me. Another thing, how are you supporting 32 times MSAA when no commercial hardware supports anything beyond 8 times? My GeForce 1080 supports 32 times MSAA. You can't really tell any difference between that and 8X. But like, yeah, I mean, like this sentiment is very common. That like MSAA cannot be used with deferred rendering. Everyone insists on this, and Leadworks has been doing it since like 2007, 2008. It's so weird. And then this video should be called "Why the Leadworks Way is the Correct Way," because that's what it's really saying. So that's why that's kind of a big deal. He's saying like this is something Leadworks has been doing since forever. Okay. Are you ready for the really weird part? Because it gets weirder.
I moved from Dallas. The order of things I wanted to set up.
There was a tutorial on NVIDIA's website that was deferred rendering with MSAA. And now it says page not found. Let's take a look at Web Archive. That page was the first archive they have of it was so this is from 2015. So this is like 11 years old, and it was up there until this last snapshot they have of it is January 7th, 2026, and then the page disappeared. What is this mysterious information that NVIDIA doesn't want you to know? How to implement multi-sample anti-aliasing on top of deferred shading. Nothing very advanced here. This is stuff that Leadworks has done since almost 10 years before this article was written. That is so strange. Okay. And I commented on this, and I was like, that's really weird. And he told me that this guy tells me that this page was up until a few days before until at least a few days before the video was posted. So there's a very, I mean, it based on this, I mean, it really does look like NVIDIA took this article down in response to this video. I mean, if you told me that was going to happen, I would not have believed that. But look, I mean, it looks like, according to this doesn't take snapshots every day. So we definitely know there was one up on January 7th. He says he checked a few days before the video was posted and he saw the article up then. So it does look like they removed that article as a response to this video, which seems kind of petty to me. I mean, and he said something like, their main advantage is DLSS, so they don't really want people to be thinking about MSAA. But anti-aliasing and upsampling are two different, they're related, but they're kind of different things. So that makes me wonder, what is NVIDIA so afraid of?
They want people to buy $5,000 GPUs for AI in them so the AI can make the jaggies go away.
Do you really think that they took this tutorial down as a response to this video that's saying the Ledworks way is the best way? Which is what is, I mean, they could have titled this video "The Ledworks Way is the Best Way." Do you think they took this article down as a response?
They're known to deprecate old posts, especially when competing things are posted online.
I can't find it. That seems kind of unlikely to me, but at the same time, I can't really come up with an alternative explanation why we know for sure it was up in January. And he says that it was up, he checked it was up a few days before the video came out. So I'm having trouble coming up with any other explanation other than they took it down as a response to this video being, getting a lot of views. They saw this and they freaked out. Do you think that's reasonable? And if not, what other explanation is there? I suspect NVIDIA removes a lot of these older rendering posts to push DLS and new features when competing posts are made. Yeah, that seems like... I wouldn't have expected that. I wouldn't have thought that they would, consider that to be a threat enough to, remove to try to, censor information on their website, an article from 10 years ago. But why else would it go away right when this went up? And so that makes me...
Well, you could always email NVIDIA.
Maybe I'll ask at the next Kronos meeting. But okay. So that makes me think, what is NVIDIA so afraid of? What do they know? Could MSAA be used to upsample images? In addition to just anti-aliasing, could it be used for upsample? Is there some way that could be used for upsampling that would be more efficient and produce better results? It's not an area that's gotten a lot of research. But this guy has done some of it. This guy has done some stuff with it. And what he's doing is he's doing a 2 times upsample using MSAA. So let's see. And he's sort of combining anti-aliasing and upscaling at the same time. So let's see. 4 times MSAA image, but he's only upscaling it 2 times, so this has no anti-aliasing. This is upscaled twice with some sort of anti-aliasing, but it looks like you can get a 2 times increase in resolution with MSAA. It looks like you can probably do that. It's kind of weird because he's combining anti-aliasing and upscaling at the same time. Okay, so here's a low resolution image, and then here it is upscaled 2 times, and this is using 2x MSAA. So in other words, this is a higher resolution image. So it's 4 times the pixels with only drawing 2 times the pixels to make 4 times the pixels. Not that great of quality, but I mean, if this was 1080p, this is what it could look like at 4K. These are a little harder to compare because he's mixing upscaling with MSAA at the same time, which kind of confuses things. But it does look like there's a technique here. It does look like there's probably a viable technique that would give you pretty decent upscaling. Which means, and that tends to be the bottleneck, especially on older cards. So this could be a way to get much faster performance out of old hardware, which is what I'm primarily, thinking about this for. Because if you only have to render 25%, if you only have to perform lighting on 25% or 50% of the pixels, then you'll double your frame rate, like across the board, pretty well. Well, what is NVIDIA sitting on that they know? They must know, like, if they really feel like so threatened that they're gonna remove this article from their website. Yeah, Unreal Engine, deferred rendering, and the lack of real MSAA. Oh, that's because real MSAA is impossible for some reason, even though Ledworks has been doing it since forever. What is going on here? Help me make sense of this.
I don't know.
Well, I've always thought it was strange. Like, how far back does this go? How far back have
The 20 series.
okay.
So the 20 series introduced the first generation optical processors, and then those were being pushed for DLSS, and then those became obsolete by the 30 series, and then by the 40 series, they basically made their current AI hardware pretty much obsolete again by the 50 series, which now can do like the 4x and so on frame generation, and that's what they're looking into with DLSS.
Okay, so when did the 20 series come out?
I want to say that was around 2017 or 2018. I think it was about 2018 because I had bought the 1080 Ti just shortly before that.
Okay. So it sounds like, let's say, like since 2017. Okay, what is the mechanism by which Nvidia exerts influence on video game studios?
Exclusive drivers and a bunch of other stuff, and they also offered for projects I've been involved in before direct support, direct access to their support team, and driver patches immediately. And beyond that, there's also the GeForce Now and everything else.
And they pretty much saved Cyberpunk.
So is it possible that since 2017, studios have been influenced by Nvidia to pursue worse technologies that were bad for the player and produce worse results, but we're good at selling AI hardware?
Yes. In fact, that is what they did with the 20 series by 2018.
Okay, so before 2017, before 2017, I can tell you, like, people are just now catching on to deferred rendering. Like, I'm reading stuff like, oh, more and more studios are starting to use deferred rendering, like written today. And I'm like, guys, like, this is a 20-year-old technique. Like, this was introduced by Stalker, Shadow of Chernobyl. They were the first game in the world to use this technique. And then Leadworks started using it, like, less than 6 months later. Leadworks 3, maybe. It launched with a forward renderer, and then I converted it into a deferred renderer, like, after the first month, after it took me like 30 days to do it.
Wasn't Leadworks 2 deferred rendering?
I guess. Probably. I don't remember which was which. Yeah, I guess it was 2. But, at the time, everybody told me I was wrong. And I just kept using it. And then everybody else started using it. But deferred rendering, and especially deferred rendering with MSAA, for some reason, it's like artificially suppressed. Like, everyone just insists that it's either not possible, or that, okay, well, it's possible, it's just not feasible. Oh, the performance cost is so terrible. No, it's not. So it's just like there's like this, so post 2017, this industry wide gaslighting is coming from Nvidia wanting to sell AI hardware. Where does the pre 2017 gaslighting on this come from?
Nvidia trying to sell DLSS.
No,
I was about to say it'd probably be the super sampling actually with what was it called, the super resolution thing they did along with their own, I think it was it DLAA or some other thing they were pushing.
wasn't the super resolution, wasn't that Nvidia AMD?
No, it was I can't use it right now because of my monitor setup, but it was the thing where you could make your 1080p screen a 4K screen by just internally upscaling it.
What do you mean?
If you have an
internal
NVIDIA
boosting?
card, yeah, if you have an NVIDIA card, it's been in the driver setup since I want to say like 2010ish. Like they pushed that way early.
So that was another. That is so strange. And anti-aliasing is the target for all of this, just because it's something so simple and basic, and that every game makes use of it.
Something I would, well, what I used to do when I was running a single monitor setup, and I'm still using that monitor as my second screen right now. It's a 1080p screen, but I would go into the NVIDIA settings and I would do 4x sampling on the Windows side so that the screen thinks it's 4K. Then when I would run games on it, those games would run in 4K, but on a 1080p screen, you basically got the upscaling, super sampling effect going on without running any anti-aliasing. And that was way early on. They were basically just brute forcing the method, tricking the monitor into thinking it was higher resolution.
Yeah, I remember doing this with Portal 2, and the crosshair was like really tiny.
So you guys are saying, basically saying that there's a 20-year-old.
I think you can do that XRT on AMD. I just don't have an AMD card to try it on, but I know it was something that AMD was looking into. And NVIDIA actually has a video on it. I'd have to try to find it because everything's covered up by DLSS now. But there was a video they had on their channel where they were bragging about how they did the 4x scaling for monitors and all this stuff to give a sharper image. And that was before the AI push.
Wasn't that before? Didn't they call it DLSS and then they just used the same name?
It wasn't
for it to-
DLSS. It was like I think it's still in the driver. It's like super resolution or something like that. It's some weird name they gave it, but I can look into it.
I know AMD had something they called super resolution, and it was just they were rendering to an image that was 4 times bigger, well, twice the dimensions, 4 times the pixels, and then downsampling it. So it's super sample anti-aliasing, which is slow as hell. But you guys are saying that there's like this 20-year-old behavior of steering developers away from viable methods towards proprietary methods, specifically in the area of anti-aliasing and upscaling.
Yes, yeah. I mean,
Kind of. It's more like NVIDIA was trying all this stuff over the last 20 years, give or take, trying to slowly brute force their way in to get crisper images.
But why is the general consensus that MSAA is impossible or impractical or not worth it, or you shouldn't be talking about this and you're a bad person for talking about it? That's kind of the feeling I get. I can't really explain to you why it's bad, but you're a bad person because you mentioned it. I mean, do you guys see that? That guy in the comments was doing it to me.
I never paid attention. I just use MSAA because I prefer it.
Yeah, but I mean, that's what I'm saying is like there's okay, these people are all getting their cues from somewhere. And I have seen stuff from like game studios like Crytek, for example. They'll put out, information saying that, oh, this is a bad idea, blah blah blah. And then all these people who make comments on Reddit and YouTube, they pick up their cues from those sources of information, and they repeat it as if it's their own opinion.
You could see it there in the side chat, Josh. That's what I was talking about. That's a very old thing they were trying way back.
oh yeah, DSR. That's what it was. I know
remember
it was.
that
I know it was like.
acronym.
I remember.
Pepper Ridge Farms remembers.
And yeah, AMD ended up copying NVIDIA after that because it was such an in-demand feature.
Let's take a look. Dynamic super resolution. Maxwell.
In peace.
The grass flickers and scintillates. Scintillates. What does scintillate means? It's a cool word.
Blurring, kind of flickery-ish kind of look. Essentially, this was just a cheat to make your monitor look higher, like sharper imaging, and then internally it was thinking it was higher resolution and rendering at that resolution, so you could bypass running things like MSAA or other AA protocols because your image looks just fine to you. I would run this very often when I had a 980 Ti, a 1080 Ti, and so on. It ran just fine, and I think that was the intent.
Well, if this and DLSS and all of that was indeed a better solution, then why would they pull this article down?
Well, that's the question, isn't it, when it comes to NVIDIA? There are so many things they do with a lot of their old articles that disappear.
Well,
Usually
in
it
a
has
way,
to do
that's
with
not
something being
surprising to me,
competing.
but I have a hard time, like, accepting any other explanation than this was a response to that video. Because we know for sure it was up January 7th, and that guy says that it was he checked a few days before, he was reading it a few days before his video came up. So, I mean, unless anybody else has a better explanation, this had to be removed in response to that video, right?
The video is going more corporate support than private support, so it could be part of that.
What's that?
The video, the graphics, and the memories all being pro-corporate for data center, AI,
Yeah.
and other world needs at a higher corporation level than the private use.
Yeah. This makes me wonder, like, what do they know? Is there some technique that you can use?
Well, isn't I think AMD's FSR open source?
That's
Couldn't there be a
temporal.
way you could?
Yeah, 1 and 2. I think 1 is just an image process with, it's like an edge enhancement thing. FSR 2 is temporal anti-aliasing. FSR 3 and 4 are AI built on the, like, featured in the hardware. But what if there's a way to use MSAA data, that jittered grid? So let's take a look at what MSAA actually is. MSAA is, it gives you, it's not super sample anti-aliasing. Like if you have 2x SSAA, that means that instead of rendering to a 19 by 20 image, you're rendering to a 3840 by 2160 image, and then resizing that down to 1920 by 1080 with like a bilinear filter. So each pixel is the average of 2 pixels, and that'll give you very high quality um, anti-aliasing. Unfortunately, you have to render 4 times as many pixels. Multi-sample anti-aliasing is a little bit different. It will render for 2x MSAA, it only renders twice as many pixels. And it uses this jittered grid. I think like each pixel, this might be rotated around so that the offset is a little bit different. So there's some randomization. But if you have 2x MSAA, it gives you something that's pretty close in appearance to 2x SSAA, but you only have to process half the pixels. The savings getting...
Just be advised that when you're doing more pixels, it's going to require more memory usage per whatever you're trying to program on the video. And the demand on the video card, you just got to make sure you have enough memory to support the entire graphic.
Yeah, certainly. But here's where it gets interesting. Like, so SSAA, that would require 4 times the memory and 4 times the processing. MSAA only requires twice the memory and twice the processing of these pixels. So you have to perform lighting on, instead of performing lighting on 4 pixels, you only have to perform lighting on 2 pixels. And because you have this rotated random pattern, it gives you something that's pretty close to what would otherwise be twice as expensive. Now, when you get to 4 times MSAA, this is giving you're using 4 pixels, but you're rendering an image that's 4 times. It's the equivalent of rendering 16 times the pixels. So your savings is enormous. When it gets to 8x MSAA, this gives you something that's pretty comparable to something that would require rendering 64 times the pixels. So your as the resolution gets up, your savings gets greater and greater and greater. And of course, we can do up to 32 times MSAA, which is pretty much, I mean, really like 2x is good, 4x is great, 8x is a little bit better, almost indistinguishable, and beyond that, you probably won't even be able to see the difference. So, I mean, this is like low, medium, high, and then super high. Probably won't need it, but if you have the extra power and it doesn't slow your computer down, then 8x is, you could use it. You probably won't ever even be able to see 16 or 32x. You probably won't be able to distinguish between that and 8x. But so the savings here is really, really spectacular versus super sample anti-aliasing.
But just be advised, since we are making programs for those that's in the population that may not be able to get the higher memory and the higher graphic cards because of supply diminished by the corporate.
Right.
We may need to go on the lower end in order to support the lower end machines so that the masses can actually enjoy the game. And they can themselves upgrade according to what's the maximum programming of the image, so that it can support a wide range of machines so more people can enjoy it at the level that they have their machines at.
Right. So this is all stuff that LEDWorks 4 does and LEDWorks 5. But what if instead of using this for anti-aliasing, can this be used for upscaling? Well, that guy did it. And I don't think his focus is on performance. And he's also mixing, in most of these cases, he's mixing anti-aliasing together with upscaling, which kind of confuses things. But I'm pretty sure you could use this 2x MSAA. I'm pretty sure you could use that to render a image at 1/4. You could use that to render 1/2 the number of pixels. So if you have a 1920 by 1080 image that you're drawing, What is 1920 divided by 2? I don't know. I can't think. 860? No. Yes. I can't think right now. But 960, right? 910. I don't know. I can't think and talk when a video is. My IQ just drops like 20
It
points.
is 960.
960. Thank
and
you.
960, yeah.
Yeah, when I know the video is recording, it's just okay. So
We all understand on the spot, the brain doesn't operate versus if it's in a private setting.
well, that and I can't talk and think at the same. Like I'm not a verbal kind of. Like those are two completely separate like sides of the brain or something. Anyways, like so 960 by 1080 divided by 2. So 960 by 540 image. And then it's 2x, so you're rendering 2 pixels for each one of those. So okay, so it's that twice. So in other words, you're rendering half the pixels. You have to perform lighting on half the number of pixels that you would have otherwise. And it appears you can probably upscale that to 1920 with some loss of quality, of course, but it sounds like it's probably pretty reasonable. And you would get a 1920 by 1080 image without anti-aliasing, and you're only rendering half as many pixels. And we know that the pixel shader tends to be the bottleneck in most renderers, including Leadworks. So right there, that is a way that we could double the frame rate across the board, not just when you're adding a lot of objects to the scene, but like it would be an obvious improvement that would be running everywhere. Right, like that right there could double the frame rate. Well, here's an even more interesting question. If we render to what is 1920 by divided by 4, 960, 450, so 480 by that times 9 divided by 16. So if you're so in other words, if you're rendering to 1/4, 25% as many pixels, can we upscale that? Can we use 4x MSAA to upscale that to 1920 by 1080 while rendering 25% the number of pixels?
I believe you could.
That is an
You're actually
interesting
getting
question.
you're getting into something there, Josh, that is actually tying back into what we were discussing regarding NVIDIA's DLSS technology. That's kind of what they're doing, but they're using a data set that basically assumes what those pixels should look like. And that's what you run into with all those little flashes and errors and artifacts from frame generation or predicting what that is. That's why I think the brute force method in general hardware today is actually much more hardware agnostic, and maybe that's why they're afraid of it.
So do you think there's a technique whereby you could render to 25% the number of pixels and get a reasonably good image quality of like 1920 by 1080? And if so, that would increase the frame rate by like right off the bat that would increase your frame rate 4 times in most games.
Yeah, it's a factor of 4 frame rate increase, but as far as I know, if you're scaling down to the 480 pixel range, you're going to get a lot of shimmering, a lot of issues. So you would have to create or have some method to actually smooth out those pixels to get them to display properly. Otherwise, you're going to get that weird kind of fuzziness that a lot of methods tend to run into. I actually mentioned in the side chat about how one of the solutions that consoles kind of moved towards was using like 2x MSAA just as the base level, and then jumping it over to FXAA to fill that in, but you still get the blurring and some odd issues.
What if you make it in the smallest format and then increase the size and see the image in the larger size and adjust accordingly to the larger size?
I don't follow you.
from the smallest resolution and you double it and see how it looks and then double it again. And then according to the distortion of the doubling, finite according to the putting in the programs to adjust for the larger image.
Well, yeah, I think that's kind of what we're trying to do. But question is, what I don't quite get is what I'm kind of thinking is this rectangle thing here. I'm assuming that this has got to be I'm assuming this has got to be randomized. So in the next pixel, it's probably rotated a different way. Because otherwise, if you were doing 2 times MSAA, then you would get these. You would get like a really jagged line at 45 degrees. Like some edges would just, if this wasn't randomly rotated, then some edges would just have this weird jagged edge as soon as they hit the right angle.
That's actually the solution that FSR3, FSR4, and DLSS try to solve. Is they use the motion vectors for each of the pixels to render that, to try to smooth out that image. And I'm sure that could be done, but the only methods that I know are going to be blurry if they're not done with some higher order processing or spitting out an excess frame that's scaled up to the frame buffer and then using that to draw the scene. And the problem is that uses up way too much memory and it'll decrease processing time, like 80 milliseconds kind of thing. And that really depends on the scaling factor, the resolution in which you're pushing.
Well, if that's so, why is NVIDIA worried enough that they pulled this article down?
Maybe there's something in there that they don't want people to know. I just don't know what that would be, because I'm trying to think through how you would do this with MSAA, and I've read through that article before, the one that you had pulled up. I'd already seen it before because I had tried to work on something like that, and I never found quite a good way to pull that off. At least not performative, at least.
Very interesting. Very interesting. Yeah, I definitely wouldn't have expected them to. I wouldn't have expected them to like pull that article down like that, but I can't think of any other explanation why it would have happened right then. I mean, it seems kind of like petty to me, and like it seems like something that they shouldn't really be worried about.
When it comes to corporate secrets, they worry about anyone being able to have access to anything that could undermine their operation.
Okay, so what you're saying is that there's some way whereby MSAA upsampling, there's some way that can undermine their operation. What is that way? What do they know?
They know, but I do not know what they know. But there's something in there that is sensitive to the way they operate under their organizations that they do not want exposed, or even the probability of being exposed is probably the reason it was taken down.
Exactly.
Well, looking at their article is older rendering techniques, but if we check the page, the one that you were discussing earlier, the one about upscaling using MSAA, I think there's some correlations there that could be connecting the dots. And then if you look at the video, the one that, what was his name did, the one that you were just showing, that one discusses the actual methodologies that actually work. Meaning, I'm sure if you had you or a few people sitting down working through this, you could probably figure out something that would get you a good performance with almost a non-AI loose approximation of something like DLSS 2.5 or 3. And if that's the case, that's market competitive, meaning there might be further optimizations.
And they do not want competition be against their set they don't want competition. They want to be part of the solution themselves without being able to share what the solution is.
Yeah, I mean, so that's basically what you're saying. That's why it really got my attention. Like, honestly, like I wasn't really even thinking about it, and then I was like, "Wait, why is this article gone? This doesn't make sense. Why would they do that?" All right, so James, your job this week is to find the answer to that question, and we'll meet again next week so that you can share your findings with the audience.
Not a problem.
Yeah, isn't that weird, guys? It's like, I mean, to me, it's just this like mundane little detail of the LeadWorks 4 renderer, and I kind of had given up trying to convince anybody that it was a good idea. I was just like, okay, I'll just keep doing my thing. And now all of a sudden, it's the thing that's going to take down NVIDIA.
Oh, I don't think you'll take them down on that one as a joke. I know, but like
I'm
their
exaggerating.
DLSS is too good.
Yeah, it's not taking them down. They just don't want the competition or something that could be used that they know on the inside could be used against them in the future.
Yeah, so if there's anybody in NVIDIA, feel free to reach out to me. Your secrets are safe with me. I won't tell Jensen who you are.
Regardless if they trust you to keep them or not, I don't think they're going to divulge insider information that they don't want divulged publicly.
There's maybe they just, I don't know.
Here's a question quickly for you, Josh. Something I was thinking about, like I had mentioned regarding the MSAA plus FXAA. With TAA, you get that really kind of muddy-ish look, but that TAA does, I think, the motion vector calculations. I don't think MSAA supports that, does it? That's just a general kind of, that just generally just sharpens the image from the, not sharpens, but smooths it out by generating that extra little nonsense that you were going over. I'm just curious, what is there a way in MSAA to do at least partially what TAA does, or is that completely incompatible?
They are two different, the way they operate is two different ways versus, I mean, you would either go one way or the other. It's like programming in one language.
This is what I was talking about right here, John.
To another.
Let's see what the article says. Temporal super resolution via multi-sampling. That's exactly what you were asking about.
Yeah, and it's an interesting article because I was reading through it before when I was trying to find a solution, but it seems like there's some issues in how the system is trying to generate or really smooth out the pixels. It's very strange, but it seems like the two should be compatible, and I still don't know how it's supposed to work.
Yeah.
They're probably programmed differently according to what you're using, and you've got to have the same format regardless which way you go in order for it to display what you want.
Well, in general, like I'm kind of negative towards any kind of temporal technique because one, they're really hard to do, and two, I think it's the kind of thing where it's just going to be endless tuning, like going on and on. People are going to find some other situation that doesn't work quite right, and you're just going to be tuning it forever. So
this also could tie into the NVIDIA question as well, because I know within DLSS, because I've worked with it quite a bit, because of the way that the motion vectors work, that's integrated directly to the sampling situation for the scene. That's why it has to be integrated by the developer to the engine, and that's what later FSR is doing as well.
Okay, here we go again. Here we go again. He's even doing this in this article. He's doing it again. This person is saying that the biggest problem, and it's a big one, is that you need to have an MSAA render target. Games rely on rendering techniques like deferred lighting, etc. They can theoretically be done with MSAA, but in practice, it's a maintenance nightmare full of little performance regressions. Really? It's a maintenance nightmare? I don't feel like it's like a slightly different. It's not difficult. Like it's way less complicated.
Why don't you email him?
The stuff that
Yeah,
he's
ask
talking
him
about
what engine he coded.
Yeah, email him about your engine and see what he thinks. Maybe he can actually help you out because he's got a lot of good information.
The stuff he's talking about is extremely advanced, and then he gets down to, talking about rendering to a multi-sample texture, and he says it's a maintenance nightmare. What? It's like 2 lines of code, bro. You just have to declare a sampler 2D MS instead of a sampler 2D in your shader.
You should just make a video where you do a simple OpenGL renderer and say, I'm going to do the impossible. I'm going to add MSAA to this render.
But you
Add
see
2
this,
lines.
you see this everywhere. Everyone insists that it's so difficult, and
Reap is right. I was gonna recommend this earlier. You could make a video on this and then show people like this is what you can actually do for the rendering pipeline. This is how it works. The question is, will that actually make a difference? The answer is probably not.
Everyone
but it
will
might just
ignore
annoy
it.
people.
And no, because what happens is you have these like
People would
discussions.
argue with you.
Yeah, you have these discussions like on Reddit and stuff, and I'll go in there and I'll say, no, actually, this is actually really easy. We did this. We've been doing this for a long time. Blah blah blah. And then I'll come back a year later and everybody insists. Like there's just this. Everybody just knows. Oh, deferred rendering and MSAA. Oh, that's so hard. That's so hard, bro. Like it's so weird. I'm trying to figure out like where does that come from? That attitude, that idea, because it's completely wrong. It's like it would be like like, and it's said by like people who are very smart, and like I don't understand most of the stuff this guy's talking about. Like, I mean, this is going into some really a lot of depth. I don't understand a lot of this, but then you get to like, it's like he's doing like advanced, calculus and theoretical physics, and then he gets down here and he's like, oh, 2 + 2, I don't know, I don't think those numbers can really be added together.
This is the thing that I run into that I annoy Reap with, and I know I've annoyed you with in the past, is when you start creating these complex interlinked systems, you start making the assumption that they're actually much more complex than they are, rather than breaking down each of the individual pieces to try to create a optimized like path. And I do the dumbest stuff like this too. I'll be like, okay, that's completely impossible. You can't do it. And then I find out a week or two later, yeah, you fucked up here. You just have to go back and change this.
It's so weird. Like after 20 years, I've been doing this for almost 20 years, and everybody's like, oh, it's theoretically possible, I suppose. And he has multiple, like explanations why. First he says, it's possible, but it's a maintenance nightmare, and also the performance is terrible. He's switching like his rationale. He's switching his rationale around, that's something people do a lot if they're lying. So he's just, it's like there's like this conspiracy of people trying to like on this one specific little mundane topic, this little mundane basic detail of renderers, like everybody's trying to like, are these people all being paid? Like this doesn't make any sense. It's like, oh,
if I had
it's
to
a
guess,
maintenance nightmare. You can't do it. Okay, well, yeah, it's possible, but the performance will be terrible. But it's so difficult. It's so difficult, and you're a bad person for asking about it. So shut up. Stop talking about it.
Do you remember, Josh, in the early 2000s?
What's being rendered and the collision that has to be set up for what's being rendered is 2 different formats, so that the reflection of what's rendered and the collision between the different objects must be programmed so that they are interact with each other. And at one state it's stable, and at another state it becomes disabled.
I don't understand that.
Between different objects is programmed with a rendering that is being programmed to be displayed, and the collision between the different objects and the reactions would be different according to what's being rendered on screen.
Like actually having like physics based on, that would be difficult. When you say collisions, do you mean
that's
physics?
what I think. Yeah, that's what I think that's in reference to is because of the way it's programmed, it would become a nightmare to try to have the different resolutions of setup and having the same reaction where it's at one state it reacts this way and at a higher state it reacts a different angle, different projections according to what's being displayed on the screen.
Are you talking about reflections?
As an example.
No, because you have actually so. No, it's really easy because you have access. What you're saying is you're. Okay, I didn't understand what you were saying at first, but basically
Because of the different resolutions that you're setting up, depending on the screen and the display and the different reactions according to one setup versus the other, the physics would change according to what area of the pixels it would hit on.
Okay, so physics is a little bit of a confusing way to describe that. I would say let's look at lighting. When you're calculating
Yeah, lighting would be the same manner.
When you're calculating lighting, you have access to these original pixel data, and the lighting is calculated for each of these. Because if you merged these, if you tried to merge these are each going to have a different depth value. So if you merged the depth value, then you performed lighting on that would not give you good results. What you do is you perform lighting on each of these pixels, and then you merge the resulting color of that. And the same thing goes for SSAO, which is why the LEDWorks was mentioned in this video. The way we do it is we perform the SSAO on each of these pixels. So you're not merging the pixels and then performing lighting on them. But the magic here is that 2x MSAA only requires, it gives you something that looks like 4 times as many pixels, but it only requires 2 times as many pixels. So you're only calculating the light twice as much. And here's a question. Is rendering 2 subpixels more optimal than rendering 2 pixels? I mean, is rendering 2 subpixels on 1 pixel, is that somehow faster on the hardware than rendering 2 separate pixels?
That sounds more like MLAA, the morphological anti-aliasing perspective, which, what was that, like 2009 when they started pushing that?
Yeah, the higher you're rendering, the slower and more memory you're going to take in order to process what's being displayed.
Right, but here's my question. Is if I was rendering 100 pixels like this, or if I was rendering 50 pixels like this, where you have 2 subsamples within that pixel, would those render at the same speed? Or is there possibly some optimization in here? Because I don't see a 2x increase I don't see a 2 times slowdown in most renderers in our renderer when you use 2x MSAA. It's more like 30% slower. So
wouldn't be going from 100 to 50, being it's 50, wouldn't the render even be faster? As it's going down in order to render, it has more time to react to render on the screen.
What I'm wondering is if maybe in the hardware there's something that says, okay, the rasterizer found 1 pixel. Now this 1 pixel, we're going to split it into 4 subpixels. And these 4 subpixels have a lot in common. These are very, very similar. There's a lot in common for these 4 subpixels. Do you think it's possible that these 4 subpixels, once it gets to that stage, do you think it's possible that they might have so much in common that there are optimizations the hardware makes that makes rendering 4 subpixels faster than rendering 4 separate full pixels?
It would be 4 times the speed because it's all doing the same thing. It's just
Is it?
displacement of the pixels that's being displayed on the screen.
Is it doing the same thing? Is that the same? Or is that the same
Josh,
task?
I gotta ask you. What you're starting to describe is starting to sound like 20 years ago when they were working on CSAA.
What's CSA stand for? Counter-Strike
That was
anti-alias?
what coverage sampling anti-aliasing, which was
Okay.
a NVIDIA project, and they kind of pushed that to show that MSAA was outdated at the time. That's another NVIDIA thing. Here, I'll put it in the side chat for you for look over.
This would be very interesting to know if there's some sort of batching behavior that goes on in the hardware that makes 4 subpixels faster to render than 4 separate pixels. If that's the case, then you could use that information to that would make upsampling very, very efficient.
Well, I think the
Yeah,
whole point of
because you could
MSAA is
just
that
take a batch program that renders the pixels and knowing how it's going to be displayed on the screen as one block of information versus doing it 4 times or 8 times or however many times it's going to be displayed.
Yeah, that's kind of what I'm saying. I don't know enough. Like, I mean, only somebody who's like really familiar with the hardware would know this stuff. So if you're a hardware engineer, feel free to reach out and let me know. But that's an interesting. I would not be shocked if that turned out to be the case.
Well, I know the programming and the standard of programming, but I don't know if these companies is staying with the formal programming like the ASCII code. In order to program everything within house, they could be changing the codes completely so that we do not know how they're being programmed or displayed on the screen because it's no longer following a standard format.
Well, it's probably not even the code. It's probably more how the hardware is designed. So, but it could
it's
vary
hardware
greatly from,
and software that handshakes with each other in order to know how to react.
I mean, it could, it could vary like based on the hardware. It could vary based on the driver. So yeah, that's like in the category of things we don't really know, and that's why like some abstraction in graphics APIs is actually really good. And why the Vulkan approach is wrong. So again, like it really makes me wonder if there's some technique to be discovered that NVIDIA knows about.
They don't want us to discover it because it's inside their organization's secrets that they don't want released to the world.
But you'll have it ready next week for us, right?
Oh, I'll do my best. I'm not certain. I mean, I'll figure what they're doing and I'll divulge that, but I don't think I'm going to get inside exactly what they're doing.
Yeah, but I mean, you'll discover the right technique, and
I certainly will.
Okay, good.
Very quickly, Josh, I just wanted to say I'm digging through some of my old development stuff, and I was going over the various anti-aliasing methods, and primarily going back about 25 years to the early 2000s to about the development of the Xbox 360 and everything. Even though that was AMD hardware, a lot of the optimizations on the software side came out of NVIDIA, where they developed things like CSAA. They were working, I think it was AMD and Intel worked with MLAA, and then NVIDIA was the one who really started pushing FXAA. And a lot of these seem like solutions that are either derivative or countering some of the shortfalls of MSAA from about 20 years ago. So it seems like NVIDIA was always highly invested in somehow superseding the MSAA pipe, which is why we don't have the solutions that I think you're looking for.
But remember, we went from 32-bit processing to 64-bit between then and now.
Well, we had 64-bit processors in the late 90s, really.
They weren't common.
Yeah,
they were not
that's
common,
what I
but
was
they
getting
were
ready to
there.
say.
But what I think is really happening here is NVIDIA is slowly pivoting, and when they get challenged, I'm sure if you went through their entire catalog of their history and you started piecing this together, and you see how their mechanisms for essentially per pixel rendering and all that is working, you'd be able to figure out a solution for some sort of MSAA upsampling or whatever, and you'd be able to get something out of that. But it's never going to compete directly with DLSS because DLSS is AI hallucinations. And I know from my experiments with DLSS, I've seen it completely fill in a scene without any issues going from like 480p all the way up to 4K. Of course, you still get shimmering and some weird temporal issues, but that's more of a VRAM problem and storing something in a data set. Now, when it comes to MSAA, most of the solutions I've been able to find are basically MSAA plus FXAA or MSAA plus CSAA, and those don't really give you that super sampling quality, and they also have their own drawbacks, especially with like FXAA or like TAA, which gives you the blurring or like weird, almost like you smeared Vaseline on your image kind of look.
Of course it'll be better than DLSS because DLSS doesn't work on 55% of consumer GPUs.
Well, that's the point, and those GPUs are cheaper.
What if there's something in there that will allow us to give those old GPUs new life, like say double the
That's
performance?
what I'm looking into right now.
Double the performance.
I'm actually looking into that.
I mean, who cares about 4K? Like only 25% of Steam users have a resolution higher than 1920 by 1080. Only 25% of people have anything higher than that, and like 30% of that, or I don't know what percentage. Like the bulk of that is 1440, which that's not halfway between. I actually thought that was halfway between 1920 by 1080 and I thought that was halfway between 1080p and 4K, but it's actually like a third or a fourth.
1440p? Yeah.
I was kind of, I don't know, for some reason I thought that was like the halfway point, but then I realized it wasn't.
The interesting thing right now is the majority of users today are either between like a 3060 or the AMD equivalent. I don't remember what GPU that is. And if you make it hardware agnostic, which MSAA is, or at least any functions you make off MSAA would be just like FXAA or any of that, that's well over 50% of the average computer user. And after that video and after that article being pulled, and then I'm pulling up some stuff more on like older anti-aliasing methods, I would guess somewhere within all of this, there are definite solutions to doing some sort of MSAA-based upscaling. And I think you could probably extend it. Again, this would be an iffy situation, given that you only have like the 2 points on the pixel to really render from at 2x. But if you have that, I think there's a way you could actually predict, probably with, I don't know, I'm trying to think through it. You could predict what the other parts of the pixel would be next to, and you could do some sort of pseudo CSAA or some sort of other sampling of that scene data, and you would be able to get upscaling straight out of that. How to do that? I don't know. It's probably way outside my skill base, but I'm still reading into it.
What if there's a way in there to get something like a GeForce 1060 to render, because the problem with those cards is always going to be the pixel shader pipeline. The pixel shader is always going to be the bottleneck for those things. What if there's a way in there to get a 1060 to render at like 1440p? What if there's a way in there to give new life to a bunch of old hardware, and suddenly it runs twice as fast?
I mean, what is that? Like, 1060 was what? 2016? 2015-ish? I think 2016.
The only problem with that is the old hardware was not designed to be used as the modern hardware is designed to. And they weren't thinking about what was the abilities of today versus what was being created then.
No, but MSAA, this technique goes, I mean, this goes back like a long time.
The MSAA goes back to what, the mid to late 90s or something, and when it was developed, I think, right? Or was it even earlier? I don't remember now. It's been so long. But I'm trying to think with the 1060, I mean, what do you have? Like, I want to guess somewhere in the 60 to 100 texture maps. The frame buffer wasn't very good. I think you're at like 190-ish gigabytes per second. You could probably do it if you were able to. I mean, I don't know. I would have to do the calculations on that. That actually would be interesting. If I had the hardware, I'd just do the test. But again, you'd need an optimized form of MSAA.
Yeah, I'm just talking the hardware design by those that's creating the hardware and what was permitted by what was being created at the time, and the inhibitors so that they come out with better and greater hardware at a later date and time.
Well, is it really better and greater? That's the.
Well, as they were able to make microprocessors and better capabilities as they advanced forward that was not in the previous sets. The programming may remain the same, but the reactions according to the ability of the processors has become much greater.
So this guy is showing us, he's showing using 2x MSAA to render to twice the resolution. So in other words, he's requiring half the amount of pixels to be drawn. See, those are the subpixels that are actually drawn, and then he's filling in the blanks. Do you think it's possible to use 4x MSAA, so 4 pixels, to represent 16 pixels and fill in the blanks?
So.
Well, doesn't
Yes.
he discuss that later in the article?
No, he doesn't. That's something he does. He never goes beyond. He goes into like upscaling combined with. It was kind of confusing. He goes into upscaling combined with anti-aliasing. So, like his final image here is. He's doing a 2x upscale with 8x MSAA. So that would be the equivalent of rendering a full resolution image at 2x MSAA, right? Because he's starting at half the resolution, and then he's for each one of those he's rendering. So it's a quarter of the area, and he's rendering 8 of them. So that covers 2 full images. So this is rendering the equivalent pixels as 2x MSAA. He never does like a 4 times upscale in this.
Well, looking at some of his math, I haven't worked my way through a lot of it. The question is, what if scaling it up by another 2 times causes a greater performance decrease that's not functional or not practical? I don't know if that'll do that, but it's an interesting article.
If you could do 4 times, if you could scale up 4 times, so that means okay, it's 1/4 the dimensions, so it's 1/16 the area, but you're rendering 4 times, 4 of those. So it's like if you divide the image into 16 parts, you just take the top row, those 4 across the top, and that's how many pixels you're rendering. So you're rendering 1/4 the number of pixels, and then upscaling it to 4 times as many pixels. If you could do that, you could increase, all those old cards would get like a 400% increase in performance immediately. Let's say 300% if you account for like the time it takes for the upscaling to work. I don't know if that's possible.
That's kind of what I'm thinking, just trying to read through what his math is saying. Is it seems like you're not going to get like the peak performance. You might, if you're really lucky on older cards, like using the 1060 as an example from his work. If you get this to work at 4x, I mean, you'd still be you would lose a good chunk of the performance, but you get a substantial performance gain from MSAA.
Yeah,
I don't know how to do
it's
that.
basically a post-processing effect, so that's going to have some cost, but.
The question is, what's the cost offset from doing the lower scale to higher scale rendering? And that would be the interesting thing to work through his math on.
Well, what if NVIDIA already knows?
I know,
They
right?
probably do, and it's just common knowledge with them.
That's
So
that's why
here's the
it
thing,
got my
though.
like I wasn't even paying that much attention, and then I saw that he pointed out that article was pulled down. I was like, okay, there's something here.
Wait, what the average GPU today, like you've covered before, is the 3060, right? Give or take on par with AMD. The general power range for the GPU.
I don't know if average is the right term, because the
Median, I
average would
guess.
be, if you averaged that, it would be well below that, because
It'd be well below, yeah. So it'd be like the median GPU or like the middle GPU,
I'd say
whatever.
like 45%. Uh, I'd say that's like the top 30%, top 35%. I'd say.
Yeah, and that's what they're aiming for with the Steam machine. But yeah, if you could, and I'm not saying this that you should do it. I'm saying like I'm still trying to work through some of his math because some of his stuff is way above my pay grade. But I don't think you'd be able to do this appropriately on something like a 1060. I think a 1080 Ti will do it, or a 1080 maybe,
Why not?
maybe even the 1070 Super or whatever the fuck it was, the one that was like
Yeah.
yeah, that one might be able to do some of this, but again, you'd be really pushing the limits on the throughput of the GPU. Depending on what your scaling factor is, 4x even at sub-pixel ratios is still that's gonna chew that sucker up. That's not gonna be great. If you're trying to get it up from 1080p, well, I mean, if you're going sub 1080p, I'm looking at like some of the memory issues here that you would run into. Just the throughput for the speed on a lot of these older GPUs, I don't think they'd be able to handle it. At
What if
least
they could?
3 generations or 4 generations ago.
What if they could? Here's
I
eight
don't know how
times.
you'd pull it off.
Here's the here's what the 8 times MSAA pattern looks like, and you notice how that's split up into. If you split that into 4 quadrants, then you have 4 pixels with 2 samples in each pixel. Again, that makes me wonder if it does seem to me that, just not based on any numbers, but my general feeling is I don't feel like 2x MSAA is twice as slow from what I've seen. I don't feel like 4 times MSAA is 4 times slower. I feel like, from what I've seen, I feel like those subpixels are somehow faster than having the same number of full separate pixels. I feel like there's some kind of batching going on in the hardware that optimizes that. Like it says, okay, all of these, we can assume that all of these subpixels all use the same, are all going to use a lot of the data. Maybe the varyings from the vertex shader are all identical for each of these, and then like some of the values are just adjusted slightly. I don't know. I don't know, like, I don't know in detail like how the hardware actually handles these, but it makes me wonder. Like, I definitely don't feel like 2x MSAA is twice as slow as having MSAA disabled. So it's very confusing to me when everybody always claims, including this person, always claim that MSAA is so awful.
Well, that's something to focus on, I guess, for the future because it's opened up some stuff for me to look into now because I'm actually really curious to see where the breadcrumb trails lead and what's actually possible with MSAA.
Yeah, it's
And it's still up to the hardware, the way the batch file is fed into and how it reacts in order to have the display that it does.
yeah. Anyways, that's something very interesting. Now's a good time to give a shout out to everybody who has recently given us a thumbs up on Steam. This includes Primar Rus, Aztec Shaman, Ananto, Pridrito, Pridrito, Nijek999, WW, Two Cats Yelling, Comunista Safado, Reap Blue, Mapache 3D. Oh boy. Tapani Neoxa, Kema 401, Alkivier Arkenstone, Garlic Waffle, 979, Materine, and Dumage. Thank you very much for adding your review on Steam. Steam reviews are very important, and it really helps us a lot. It will help Leadworks to grow so that I can keep bringing you updates and DLCs and model packs and weapons and interesting discussions like today's. So if you could add your review on Steam, I'd really appreciate it. And if you want me to, I will read your name out every week like this. So thank you, everybody. Can we get a round of applause for all these fine people?
I clapped. I clapped because I recognized those people.
Everyone recognizes them because they are very special. Yeah, so
I clapped because I recognized Heisenberg.
yeah, that looks so good. Okay, so this
It looks perfect.
yeah. You also have the more like military camo kind of style. There's several of these, but they look great.
These are the same hands we used in the demo, correct?
Yeah.
So everything will match. Very
Yeah,
cool.
yeah, I have that same exact gun too.
Are these all available to use, or do you have to purchase them, or what?
They'll be available to purchase. I'm gonna do a Kickstarter campaign this month, and that'll just cover the cost of that'll help cover the cost of the license I have to pay in order to sell these, as well as I mean it'll take like a couple of days for me to go through because all the animations are in separate files, and like the channels for the different like roughness, metalness, etc. They're all in different images, and I have to like combine the channels, and so I mean there's work to be done to prepare all of this, but it looks like all the animations, like all the models that I tested, work correctly. And there's some really cool stuff in there. I mean, he's got like a grenade that you throw. There's a grenade launcher. There's a crossbow. There's a knife. Yeah, just a lot of variety. It's really cool.
So when they go up, I assume they'll just be on Steam or something that you can grab, or
yeah, it'll be a
how will
DLC on Steam. I want to get some. We need some like the old. I took the old DLCs down because they're pretty outdated. So it's time to get new DLCs up, and this is the first one because few models are in high. Like this is the. I know from experience this is one of the things that people want most, and people also like were very positive when I mentioned this. So you'll have some very nice quality models that are ready to use with Leadworks 5.
I'll save up and maybe I'll grab them for some projects I'm messing with because those actually look really good.
Yeah, the artist does a really nice job. Okay, so that's all I've got for you this week. Cyclone is on sale on Steam right now.
I own it.
Yeah, it's fun, huh?
Well, I haven't played it.
Okay, well, it'll be fun when you play it.
I just haven't gotten around to it. I mean, I got lots of games, and I'm also programming. But I do support the community.
Let's watch the video here.
It's a gameplay video.
No sound.
No
For the
sound, but that's
best
okay.
for the best experience with Cyclone, I always advise a controller or playing on your Steam Deck. It's fantastic.
I have a F3 gamepad.
Yeah, as long as it supports Steam input, you're good to go.
Oh, I have a program through Steam.
Right.
Don't forget, one of the lead developers of Portal said Cyclone was fantastic.
Yep. This is an older video too. Yeah, there was a recent update. I merged to the default branch. The
Yeah, I
box
just
model.
downloaded the update.
Yeah, the box polygons are heavily reduced. The ball now bounces correctly off of surfaces if it's like at an angle. I also did some window fixes and
I love this riff off Chamber 13. It's so good. It reminds me of the old Blue Portal days and everything, though.
yep.
But yeah, I would say if you guys don't have it, grab Cyclone. It's really well done.
Yeah, it'll be on sale until minus 32% until Monday. So grab it now.
Yeah, everybody wish Reap a happy birthday as well. So
Yeah.
he's an old man now.
Why put it on sale?
Happy birthday.
Yeah, it was yesterday, but thank you.
It's for next year. All right. Any questions? Any other questions for anybody?
All I'm going to say is that MSAA discussion has taught me a lot, and I have a lot more to look into, and that was a fantastic discussion.
Just for my knowledge, the version 4.6 and everything that was made in it, should that all just go away? I mean, it'll make more hard disks. Or is it going to be ever be imported into 5.0?
What do you mean, the DLCs?
No, what I was creating, because it was in version
Oh,
4.6.
You can, if you right click on the application in the Steam, you can still, if you need to use 4.6, you can still install that on Steam. It's still available.
Oh, I didn't know that. I thought it was just 5, and I just got the hardware where it can function in 5. I have 2 computers available that I can program with the latest LeadWorks.
Yeah, you could probably install 4.6 on one and 5.0 on the other if you wanted to. But if you right click on the program in Steam and then go to properties, and then there's a section called betas, and that allows you to, like, all the old versions are archived. So if you need to roll back to the old version for any reason, or if you just have a project that you were working on, you can still do that.
Yeah, I was working on a project, but I don't know if it'll ever get released because it's under an older version, and
No, you can do
everyone's
that.
moved on to 5.
You can still work with the old version. That's fine. Like I made sure to.
Well,
I
I'll be
wouldn't.
doing both versions, but
Yeah, they're so
I
they're
mean,
so
I-
different that I wouldn't just force everybody to switch over, because there'll still be people doing stuff with 4.6. I think it's like 5% of people are using 4.6 still.
Well, I know I was programming heavily in 4.6 and then it went to 5, and that's why I'm asking that question. Is it ever going to be upgradable to 5 taking the old 4.6 and being able to just have it brought into the latest LeadWorks, or should I just discard it as old programming?
Depends on what your goals are. Like the code, the programming API is quite different. So that code, I mean, it's not super difficult to update. It's certainly a lot simpler. I mean, the engines are very similar, but like code has to be updated if you want to do that. The model files and texture files and stuff, for the most part, those will work pretty seamlessly. So you can upgrade to 5.0, but you don't necessarily need to. I mean, if you have a project that you're working on in 4.6, then I don't see any problem with just, staying with that until you're finished with that project. It depends on
So
what
I
you
got
want.
about 10 projects in 4.6.
Yeah, you might want to just stay with that version if you're doing well with that.
Okay, I'll be doing 4.6 for the older programs and
Yeah,
five and later for the newer programs I'm creating.
that makes a lot of sense.
I just wanted to know if they were compatible enough where it would behoove me just to upgrade to 5.0 or just disregard them as the old programs. Or, I mean, you just gave me the option of 4.6 because I just upgraded to 5.0, disregarded the 4.6 and see, and you already answered that.
Yeah.
So, I'll probably be programming on both versions.
That's probably wise.
And as far as the answer to the graphic NVIDIA, I will have that to you. I'm not going to guarantee Saturday, but I will get the answer, the full answer, not a partial answer, and I will give it to you directly as a message.
Yeah, just ask Jensen Wong next time you see him. He'll probably explain it.
Okay, no problem.
Last little bit there, Josh. Here's the real question to tie it all off for today. When are we going to get full DLSS integration and ray tracing along with RTX features?
When the number of people who can run that is more than 10% of the market.
They gotta hand you a big bag of money like Cyberpunk, huh?
Yeah, there's really like yeah, there's probably more demand for 486 support. Yeah, people just aren't upgrading their cards, and when they do upgrade, they're just replacing their card that broke. They're replacing their 1080 that broke with something that's not much better than a 1080.
Well, Nvidia is actually right now there for this year, 2026. They've announced that they are not going to announce a new series and they're scaling back production. And AMD, side to that, said we're scaling up production and we're offering better value to people. And they were starting to cut prices as much as they can by, I think, Q2.
NVIDIA also announced that the next upgrade will not come out till after 2027. The earliest that they'll even release any information will be in 2027.
Yep. That is actually accurate from what I've seen. So you can expect the 6000 series by probably Q1 2028.
Yeah,
so if you've got a 50 series or after, you're good to go.
Aren't they re-releasing
really
the
40
3060s?
series.
I just know what NVIDIA released as far as the public information, and he's accurate. 2028 would be the absolute earliest, and I'm projecting 2030 by the time the 6000s come out.
Well, I mean, we are, well, technically, actually, the next series, speaking of the 6000, we actually have the RTX 6000 from the internal stuff that's going on. They have the two new platforms they're working on, and the people that I've talked with from NVIDIA, the next series may just be called the 7000 series because the RTX 6000 is essentially a 5090 with 96 gigs of VRAM, I think, or 92. It's that one that's like $8,000, and now they're over 10 grand a piece. So I know they're working on the new mobile chips, which are targeted for, I think, next year, and those might be the 6000 chips, kind of like they did previously, and then they'll just jump gap the next generation and make it sound bigger than it is.
Like I said, what I heard is the major update won't be till 2030, and you're probably right. It is the 7,000, so it'll go from 5,000 to 7,000 with the 6,000 intermediate.
Who was it? Was it Nvidia who did the thing where they? Oh yeah, it was where they went from the 700 series. I think that was like Maxwell or something, and then they jumped to the 800 series. And the 800 series with the mobile chip branch, and then they went to the 960, 980, 980 Ti. Yeah, I think that was what it was. And I think they're going to do the same thing now between the 5000 and 7000 series, because we already have the RTX 6000, which is just an upgraded RTX 5090. It's the same chip, same SKU, same everything they did.
All right, so NVIDIA is bringing back the 3060 because they failed to get people to upgrade the first time around. AMD, I guess they're bringing in new AM4 socket CPUs.
Yes, that's actually what I was emailed about recently. They are bringing back some upgraded AM4 sockets with 3D memory and everything, and hopefully I'll be able to grab one, and then I can send Reap here my 5900X.
GDR4 memory.
Yep.
A few weeks ago, I said something like, I was like, hey, what if like average consumer specs actually start going down? And then all this stuff.
Well, I mean,
I said that like a month or two ago, maybe.
They won't go down. They'll just be at the platform, and it'll be a level platform until the new material comes out in like 2030.
So, regarding, I want to answer what XRT said here because I'm actually familiar with these GPU models, but I just want to respond to you on that, Josh. I think that's actually happening now, and that's why the Steam Machine is going to, and I know we talked about this in previous weekend workshops and discussions. I think this is going to be the big point where something with less specs is going to be more valuable because it's more attainable, and it'll force developers to actually optimize for that hardware instead of just spearheading into advanced tech, where I had built my system because we were always jumping on previous projects to doing the highest level graphics rendering. But the problem is 99% of your user base can't do that. So you're basically saying, oh, here's what the future can do. Let's aim for that future. But that future is decades away at this point.
Yeah. I mean, typically, like during the development of LEDWorks 5, I was actually worried about falling behind. But then, it turned out the opposite turned out to be true. Like now it's like, okay, I need to like do more work to optimize like for the exact same cards that LEDWorks 4 used, or in some cases even lower than what LEDWorks 4 used. Here's another prediction. I think HDDs are going to make a comeback. I think people are going to start downgrading.
I agree with that. In fact, there was actually a recent publication that actually covered that. I wanted to ask you about that because I don't have an HDD outside of my externals, but when I ran the few games that I have on LEDWorks from my externals, they ran just fine. Source Engine runs fine, LEDWorks stuff runs fine, but you try running CryEngine or you try running Unreal or you try running any of these other engines, they stutter and they run pretty terribly off an SSD.
Because they're
not an SSD, an external.
It's because they're constantly streaming data.
Yeah, exactly. That's the data stream limit. I am very familiar with that.
Okay.
XRT, by the way, asked the question, is a 4070 decent or an RX 9060? The answer is both of those are really good choices, but I would go with the 9060.
Also, what you could do is design your program on the latest hardware, knowing that you can hold on to that way it's programmed, and as the people moves up to the lower end of your specs on the program you created, you could release it at that time in like 2030, 2031, because more people will have the machines that can handle it.
That actually makes me want to ask Josh, James, another question here. So I was on, about my previous team and stuff I worked on, And so I was the one who was always building the most advanced system. And I would be doing that to push the engine all the way up to its limits. And then we would use that data to basically scale the engine all the way down. And I'm curious, are you at all right now looking into new hardware or the best hardware you can get? Or are you kind of just sidelining that and focusing just on the mid range kind of thing?
Neither.
Okay.
I'm looking for the worst hardware I can get.
That is an interesting design perspective.
Like I'm
I
actually
don't know
like
how to
I had a card that I gave my nephew, like an old AMD card, and then he upgraded. He got a 9060, and then I asked him, like, I was like, hey dude, can I get that card back? And I'm probably gonna buy like a 1060 and maybe some older hardware. Like I haven't bought anything yet, but I have been like looking around at like really old cards, because I figure if I
I
can
would
make
say I would say your limit you should draw is about the 760 range, because before that, things get a little iffy. You could probably get like I think a 760 actually would be an interesting like bottom of the tier, because 760s are actually still being used by people today. And I think the highest 760 was the one that I had, which is the 4 gig model, which would actually be a good threshold to test like really interesting stuff on lower tier hardware. At that point in time, you'd probably be looking at what, like, I don't even know what generation of Intel it would be, but you'd be looking at Bulldozer AMD CPUs, which would really be intriguing off DDR2 memory and all that.
I have old GPUs that I just have in boxes. If you
I was about to offer the same thing. In my storage unit, I might have some old GPUs that I can send you if you want.
I might be
I
interested.
I mean, they're really old.
in those. Also, like Intel, any integrated graphics is actually great to test on, because it makes it really obvious what you like. It makes it very obvious where your bottlenecks are, and you can just go through and like change one line of shader code and see a difference in the frame rate, because it's so limited.
I think
So wait. I've been playing with LEDWorks. It's GLSL. It looks like, right? Like that's what I've been messing with primarily
Yeah.
for shaders.
Yeah.
Yeah. So, I mean, yeah, you could. It depends on what your shaders are, but those older GPUs, like I said, the cutoff should be around the 7 series or 700 series from NVIDIA, and whatever. I
That's
had a
the lowest I've ever
5870
heard
back
of.
then, but I would say try it. I mean, you might be able to get something through. I don't have my 760s or anything anymore, but I'd be curious if they could do it. But I do think that the lowest you'll probably be able to go to would probably be like a 980 Ti to get actual good performance out of, which is 11 years old at this point, I think.
I have a Radeon HD 5770.
I sold mine, Reed, but yeah.
Well,
Well, we used to
LEDWorks
play
work-
on the same yeah.
Will LEDWorks work on a Radeon HD 7770?
Why don't you plug it into
Oh,
your system
Radeon
and see if
HD
you can get
what?
it to run?
A Radeon HD 5770.
That's the one before
This part.
the
That's
6600.
2009.
Oh, 2009. Okay, so that's like a full. It just depends on if it supports shader model 4.0 and if it
I don't think
supports.
it does.
Okay.
I
you
gave my
sure?
friend. I gave my friend my 750 Ti. I want to see if I can recover that. I was
Yeah,
gonna-
steal
I'll-
it back from
Reap,
him.
Reap. Wait. When you talk like so from the release, they were some of the first like really good DirectX 11 GPUs. The 5770, 5870, and all those, they all support upwards of shader model 5.0.
Well, LEDWorks 4 does work on Intel integrated graphics. LEDWorks 5 currently does not, because it just wasn't a priority, but it's becoming a priority. And if I can make it run fast on integrated graphics, then you can just assume that it'll run really fast everywhere. No, the thing I was saying about HDDs though is like people's SSDs are eventually going to break. I've had good
break
results with
eventually,
Samsung SSDs.
My
but-
entire My entire system is Samsung, and they're like 3 of them are NVMe's, 2 are SATAs, and I try to do every 1 to 3 month backups to external Western Digital, basically essentially NAS drives at that point. They're red tier drives.
But like those SSDs are going to eventually break, and when they do, people are not going to be willing to pay $250 for something that they paid $100 for a few years ago. So
we're gonna go back to how it was 10 years ago. You buy an SSD for your operating system, and you put all your data on the mechanical.
I wouldn't go that far. I would say what you're actually looking at today. Well, today the newer drives you can buy are actually hybrid drives. They have on the main board that's the controller board has like 20 to 100 gigs of like buffer memory where it's loading things off that drive to speed up the process on SATA. You're not going to get close to an SSD speed, but it's still much more reliable because you're not running through the read-write cycles that you get off an SSD.
So, yeah, like I had I was looking at SSD prices a couple weeks ago, and I was like, you know, the same thing that I already had bought a couple of, like the price had gone up like twice as much, and it's like, well, I'm not paying for that because I know I'm getting ripped off. So I have a bunch of old HDDs, so I just took one of those and I used that as a secondary drive. But yeah, even if new hardware comes out, and even if the prices come back down to where they should be, even then, I think the entire consumer market has been taught that you don't need a new computer. Even if everything went back to normal, I think people still wouldn't upgrade until something broke. Like, I think everyone's just been taught you don't have to upgrade. Like, that's the fundamental change in attitude that has changed in the last 10 years. And I think that's going to be lifelong. Like, I don't think that's going to be something that can ever be unlearned.
In that case,
they kind of want that attitude since the data centers and everything's buying up all the hardware currently to support the operation of AI and other support. So they're trying to get the general population to accept the hardware that they already have.
Well, they have, but the problem is that, like, all the spending on data centers, that's going to go away in a couple of years, I think.
I was going to bring that up just now. So the big thing that's going on in terms of hardware, because I still know people who are in the industry working on this. So they're actually withholding stock. It's not that there isn't enough stock. So the prices today are inflated because companies and stores and so on can't get that stock because they want to sell like the NAND flash memory and everything else directly to the data centers. Mm-hmm. But the problem is those data centers don't exist right now. And so that drives up the price of general consumer GPUs, CPUs, SSDs, and so on. Because what good is a AM5 processor if you can't get DDR5 memory? That's why AMD is now going to start refabbing, because they have the equipment to do it, refabbing AM4 processors, because they already have all the stuff there. They have the materials. They have everything to do it with. And DDR4 memory, my memory doubled in value. And even at double the value, it's still cheaper than what I spent 5 years ago to get it. So it's like, well, then I'll get more value out of having more memory. And by having that more memory, yeah, I'm not going to compete with any of these AI firms, but I can set up software and things in my system that I can load directly to fast memory. I have 3600 megahertz memory. Sounds slow today, but it's like, that's actually really good memory. That's better than what you'll get out of a Steam machine. That's better than what you're going to get out of most people's computers. So I do think you're right in a lot of these, I don't want to call them assumptions, I'll call it a conjecture, but it's like you're right where it's going to start throttling back down where people go, well, wait a minute, why do I need 5,000 megahertz or whatever on memory when I get the same performance off of a previous generation of technology? And I think that's where we are, and we're going to start seeing that skew kind of happening through Steam hardware survey over the next couple of years. I don't
And
think
it
that's going to
also-
destroy the market, though. I don't think it's going to collapse it, and I don't think the AI bubble is going to pop in the way a lot of people think. I think most of that's just going to be consolidation of data centers and technology and software, and that'll be it.
It's also the end user of the demands that they want from their machine, and the machines that are out today more than meets the demand of the usage that they want out of their machines, unless they're a high-end gamer or something that's a high-end demand on the machine.
So what James said there actually ties into the other point I was going to point out to you, Josh, when I was joking about like the RTX stuff. The other thing that I noticed doing engine development over the years and working in various fields like this is most users want the biggest bang for their buck, but they don't actually know what they're asking in regard to engine development. Like they'll be like, wow, I spent all this money on this big system and I can't get this fidelity I want, make it better. And like it reminds me of that TNG episode with the one alien species who is not fully there in their heads, and they go, make it go, make engine faster. And I
look
think
for
what I've
things.
seen with
Things that
Well,
make us go.
yeah, so it's like what I see in this is, I think from my experience with, I'm still playing with Leadworks, by the way. I have not finished a project. I hope I'll have one by the winter thing for this year, but we'll see. But it's
Summer's
like
the next
I've been
one.
playing with it. Well, what I see is you do a lot of optimizations, and I know sometimes I supersede those optimizations to see if I just push in something that modern rendering does. That modern rendering often doesn't give you better visual clarity. It actually just fills up your memory, fills up your frame buffer, and makes your performance worse. Oh, but my pixels are like a 20th slightly sharper kind of thing. And that's how super
we've
sampling and other
definitely
things
reached diminishing returns.
Well, that's why I love Leadworks. That's why I've been having so much fun with it. And I've been trying to figure out various integration systems with it, but I will work on that over the next 9 months, give or take. But it's very interesting to see where you're scaling down, where all these other engines scale up, and a lot of people just build a PC now, and when they put the PC together, they just crank everything to ultra and they go, okay, oh, it's not working, bad optimization. And it's like, well, most ultra features are generally experimental, and most of those are scaled off the consoles, which are using lower resolution, higher upscaling, and they're using optimized anti-aliasing techniques.
Yeah,
So
like
I
one-
see
one
a lot of this in
simple-
the industry.
One simple example of this is it's not really related to performance or anything, but like a BC7 compression versus DXT5 compression. It gets rid of the those greenish blocky artifacts that DXT5 has, but it takes about 1,000 times more. It's about 1,000 times easily more computationally expensive to perform that compression step. We managed to get it down to where each BC7 texture only takes like 4 or 5 seconds, which is like, that's a huge win. But from the end user's perspective, like it's still like 100 times slower to compress, and the increased visual quality it's good. I mean, but it's not really
I
that.
didn't-
Most people won't even notice until they're.
I was about to say, I like primarily, even to this day, because I started with Source Engine primarily as one of my main engines that I would compile textures and other stuff with, and I would get complained to by people that I was using DXT5, but who's going to notice that? In an action scenario, or you have a wall texture that you're just going to run by, who's going to sit down? I mean, I do this, but who's going to actually sit down, walk up, zoom in on the texture and go, those pixels are a little off and a little messy?
Yeah.
Nobody does that, and your performance is better.
Is the performance of DXT5 actually better than BC7?
I would say under the VC7, I don't. Actually, I think from the old days. Now we're talking back in like 2008, 2009, maybe. But I think now I don't. I think you're not even talking like a millisecond or anything. Like you're talking fractions of a millisecond.
I would assume that they're probably about the same, like the same decompression speed, but it's just the compression speed of BC7 is just so slow because it's a very complicated algorithm.
Well, it kind of reminds me. VC7 kind of reminded me of like back in the day when people thought like BMP images were better than JPEG.
They
Like
are.
it's one of those things where it's like you're not going to notice that when you look at an image.
Okay, yeah, good point. Yeah, yeah. So it's like, yeah, we've definitely reached like diminishing returns where it's like you can get something to where it's like 15% better, but it's 400% slower. Is
Yeah, and what do you see on your screen when that's displayed to you? Because like one of the things when I was working on previous projects, I would describe to people when I would use DXT5, and they would go, "Well, that's horrible. Why are you doing that?" And I'd go, "Well, I could run it through something, or I could do like bicubic or some other upsampling, like some crazy nonsense, and I could take 200% more time or 1,000% more time to really get that texture sharp." And if I slap it on a wall texture, or I slap it as like a graffiti texture on a wall, or something like that, who's going to stop, look at it, and actually allow that to have the impact that it's going to have? Other than like, I do understand your perspective though, where you're talking about where you aim for the lowest, like let's aim for the lowest hardware to get the highest fidelity, because many people who buy a lot of high-end hardware, they don't look into this kind of functions for engines. They look into it where they want the sharpest image possible, and they want their VRAM eaten up to brag to everybody. And I find that to be kind of absurd. The goal should be to do what we were doing in the 90s and the early 2000s, but maybe I'm just getting old.
optimization. Yeah, so like yeah, for that reason, like one of the changes in 5.0.2, this is available in the beta branch right now, but it actually switches
I
to
need to
using
switch to that.
it actually uses DXT5 compression by default. You can still change it to BC7, and that's what I'm using, but for most people, like they're just going to be happy with DXT5 and they just want it to be fast.
I've used, I think I was using, was it BC3 to BC5 or something before, but yeah, I don't know. I just kind of play with it. I'm curious though. I know I'm taking up too much of your time asking too much in-depth questions. So the lowest tier hardware thing, I just want to quickly go back to that. Lowest tier hardware, long term, what are your goals? Like, where do you want to aim in that range? I mean, I know that the Steam Machine is going to be in that mid-tier range. I know that you have computers like mine that are slightly above that. And I know we have people in here with little worse, little better. Like, I know you're aiming for the lowest aspect, but I'm trying to get like a general range, like long term with more advanced features that I know you're working on. Where are we going with the Leadworks project manager, editor, and so on?
Well, I think what we can pretty much count on for like the next 10 years is probably going to be a period of great stability. Because in order to, the techniques we use are the techniques we use because they're the most efficient. And the best way to increase the fidelity of those is to use the same technique and just increase your vertex counts and your texture resolutions, but just keep the same fundamental technique because that's the most efficient at one level of hardware. If you increase the capabilities of that hardware by 400%, well, those are still the most efficient techniques. So it's kind of like, I mean, we probably could have done like Quake ray tracing at 3060p in like 2015, but nobody was very interested in that.
Right. Here's the question. Wouldn't you have had much more noise or much more blurring in the scene if you were doing that, or a far lower frame rate? like what would you have done in 2015 to pull off Quake ray tracing?
You
I
could
mean,
have
you could
probably.
have
I'm
pulled
sure
off
you could have
Quake
done
ray
that
tracing
on a
20 years
CPU.
ago.
At
Yeah, I
30,
was about to
no,
say,
I'm saying
you'd
at
have pulled
like
it
a
off
very,
20 years
very,
ago.
let's say at 64 by 64 resolution, we could have done that on a CPU.
Yeah, well, that's what I'm saying. You could have done that 20 years ago on the old like dual cores with this GPU doing the general scene rendering, and then yeah, it would have been slow, but you could have pulled it off at like 20 FPS at
Right.
64 by 64. So
That's not what people want. What people want, like the number one thing you can do to increase the quality of your scene is just use more vertices.
Yeah, but that also goes back to the NVIDIA thing again that you mentioned, where what they're dealing with is they want to lower the render resolutions more and more and more internally, and then do the export resolutions to higher, so they have to do the internal like denoising and other processing, which leads to what I know you've discussed before, which leads to blurring in the scene, ghosting from an object, and all of that. So that's kind of what I'm getting at. I'm trying to figure out like long term when it comes to LEDWorks. I know you've been interested and you've kind of mentioned the idea of like better ray tracing and everything. But I guess my question there would be how would you even pull that off at this point in time? Because I don't know if the technology even fully exists to make it worth any sort of aspect. Because a project I'm working on right now, I kind of just want to have I want to call it scene saturation with a single light source, and I know I could go through the C++ pipeline, or I could probably do it in Lua. But I'm curious, like what your goal there is to actually match modern hardware and then scale that back. Would there be? I know there is the ability to bake lighting and all that, but my brain is kind of brainstorming right now, thinking through what you're going for. All of it ties into the anti-aliasing, everything else for what you can present for the lowest tier hardware. I mean, I could ray trace on a.
I have very little interest in ray tracing. It sounds like a good way to go broke and for nobody to do something that nobody really cares about.
Okay.
My feeling on indirect lighting is the industry has had about 26 years to figure out some way of doing fully dynamic global illumination, and it's all failed.
My experience in Source says it's very inefficient.
Yeah, so it's failed. Like, there is no special. There usually we've come up with graphics programmers are very good at coming up with clever tricks to do things that are like hyper efficient. I don't think there is any clever trick that will give general purpose fully dynamic global illumination. So for that reason, I'm fully embracing like a hybrid approach where the indirect lighting component is baked, combined with direct lighting that is based on shadow maps. That's a good solid technique that provides beautiful results, and it runs fast. It runs extremely fast.
That's essentially what I've seen through Source and everything else, where you create a static environment, but you also use the I guess in Source it was like VRAD or whatever, and then you use those calculations to determine the angle of light, and there you do like casting shadows or casting the light or whatever into the scene to do shadow maps and so on. And that's what I was kind of seeing with LEDWorks, which looks great. It actually works very well, but you've explained something that I was not able to get answered from the Unreal team and others over the years, because it seems like there's this idea that we have to have constant dynamic lighting, and I don't think that sounds very reasonable.
It's not going to happen. Nobody's going to do it. Yeah, I have very little interest in nonsense that's just wild goose chases that lead to nowhere. We've had more than enough time to figure this out. It's time to make a call on this, and that's the call that I am making. I have a real game coming out. I want it to look good and run fast, and that's the approach that I intend to take. When you're
What's the name of the game coming out?
It's on the Leadworks Steam account. It's called SCP Redacted.
I assume with SCP Redacted, I've asked Reap and others. I know he's helping you with it. He won't obviously doesn't tell me anything, but I was trying to figure out. So, like, are you aiming for like Leadworks 6.0 or something before that comes out, or like spitballing kind of off the record sort of conversation? Because I'm curious. Because I'm extremely curious actually about the project, given what you've shown about what it's going to cover and what it'll show off for Leadworks.
We've shown very little in terms of gameplay. The AI system is good. Alien Isolation is really an excellent. That was a really well done game. They did a really good job with that. I actually learned something from looking at that. From looking at how they did some of their specular reflection stuff. They had some clever ideas that I'm going to steal. But the only thing
Didn't they just use light probes for the local area, kind of like what Cyberpunk and others did?
Yeah, but if you look at the ground, it's showing reflections that are extremely good, and I was like, what the heck? What is going on? Like, it doesn't look like a cube map, and I finally figured out what they're doing.
Those were scene. I thought that was the scene camera thing that they had for the engine, where
what they're doing is, I think, is they'll take like a point light, because if you look at the ground and then you see something, you'll see like the reflections of these long bars of these like fluorescent lights, but they'll hide when they go behind. If you have a shit.
I know the term you're talking about, and I'm also running into the wall. Basically, the thing that's allowing the light to either pass through or tell it a yes or no, and then when it hits
it looks like it's ray traced.
Yeah, and that's what I was talking about. I thought
I think what they do
have
is
a camera system.
They take a point. No, I think what they do is they take a point light and they assign, it's a point light, but the specular, they're treating the light as though it's a cylinder shape for the specular reflection. And then I think they're actually using the shadow map to determine, to handle like whether that reflection is visible at that point. And that's why it looks ray traced, and that's why you don't see the whole scene reflected. You only see like the bright highlights reflected.
It's the angle in which you're standing when your camera looks down at it. I know the one you're talking about.
But
my brain keeps saying occulting, but it's where you're culling out it's not using, you're not using the QMAP system. And I know on the surface level, what you're doing is a render of the scene from the angle in which the camera is essentially raycasting towards it, which arguably is how lighting in the real world kind of works. If you've ever looked at tiles and you tilt your head one way and then this tile's shining and the other isn't, you're basically just doing that angle calculation.
But they did a really great job on that game. Not just the graphics, but like
that's the kind of optimizations that when I'm playing with projects right now that I'm trying to do, because those are the best ways of doing it. And when it comes to the ray tracing question and all that earlier, it's mostly like if you're already able to do that and it costs 5,000 times less the performance, depending on the and that's actually a real thing if you go back to the 20 series on performance, then what's the point of the ray tracing aspect? What benefit does it give me other than getting potentially more scene data from a lower resolution? And I haven't figured that out yet. I don't know why NVIDIA has pushed that so much.
I'm becoming much less interested in theoreticals and things that could be, and I'm becoming much more interested in actual shipping products.
Does SCP Redacted, and you don't have to, obviously you don't have to answer this, but does it use a lot of these ideas you've discussed? I guess would be the most basic way of putting that.
The only thing that we're going to use that we don't already have is the baked light map for the indirect lighting. That's like the only feature that we're missing. There'll be some other things in like 5.1 that I'm going to be experimenting with.
Well, the thing that then comes up there is indoor lighting, which is generally just you just have a lamp up and then you can calculate the lighting for the scene. The other question then comes up for outside of like projected textures or something in an outdoor environment. If somebody wanted, say, myself, which I do have a couple projects I'm actually trying to mess with, if I wanted to have the most performative full dynamic lighting system where I have, say, a sun moving across and I'm using a couple shaders to get the atmospheric like setup so it looks good as the sun moves across the scene. So what do I do? Just attach a projected texture, or what do I attach to the sun to get proper good lighting? Or if I wanted soft shadows instead of sharp shadows, what would I do there?
Well, okay, so the first one thing that I do plan on doing in the future, I am sort of scaling down like Leadworks 5 a little bit, like in terms of like the intended world size. Originally, I kind of like the original design. I kind of had it in my mind that I wanted to support like huge worlds. You know, I always like wanted to you'd be able to do like full scale like Earth simulations and stuff. And originally there was like a 64-bit float build of the engine, and all that stuff just turned out to be not. It's doable, but it's just not really worth it. And then once I started, putting when you put constraints on your design, things can start getting better. Because instead of trying to do everything, you're trying to do fewer things, and you can do a better job of it. So, like one example would be like one thing I plan on doing with directional light shadows is I'm going to at least experiment with it. I'm going to use instead of using I'm going to use one maximum resolution. Okay, so you know how like cascaded shadow maps, they have a limited range.
Yeah, and so the way that I have that set up is I'm trying to do something with like where the player's looking, but right now I'm just using a guided camera just to get the idea. And I have my resolution set to 2048 for shadow maps, but I can't figure out like how I'm supposed to do that fully. But
well, in a lot of
maybe I
games,
will.
like the shadows just fade past a certain distance, and they'll usually combine that with like some fog to make it fade out. But
I don't have fog. I don't want to do that. I'm trying to do like a dynamic scene looking thing.
Yeah, so what I actually plan on doing is just having like one final stage that's like one big shadow map that encompasses the entire world and just never moves, and it only casts shadows on the static objects, and it only has to get rendered once because it's just static.
Well, now that makes me think of the moon thing you showed earlier, because what I'm trying to do is so I want to use Leadworks to a degree as kind of a rendering engine. I haven't shown you some of the stuff I was trying to do, and I guess the idea I was thinking of is like, I have a spaceship up above the planet, right? Mm-hmm. And then what I did is I put a spotlight down, and the spotlight casts that shadow, but the spotlight has to move with what is essentially the sun, which is just a backdrop for the rendering of the map, and that just casts the shadow down. But it's very sharp and all that. And I was just more curious, like, I don't know the full inner workings of the engine fully yet, but I'm trying to play with some of those before I start posting videos and stuff.
Microsoft already created a game that encompassed the entire world. It's an
MS Flight Simulator?
flying game.
Yeah, it was MS Flight
Simulator. Yeah, it was
that's more
created where it covers the entire world.
That's more streaming. I've already worked on projects like that before, but like for me, when it comes to this, Josh, I guess the question I'm asking is maybe this is what you were trying to explain, is you haven't finished some of the systems that I'm kind of pushing up against right now, because I don't see those solutions, and I was curious if there was something I was missing. It sounds like you're thinking about it. What you want to do, I guess, is you'd create a plane, this cube, and let's say it's like 16840 by 16840. Within that range, that's where you do the projected texture, the shadow map, and then you basically have your light source and everything else, and that creates for the static objects like rocks and everything on the surface, that gives you your shadow detail, and then anything else that's dynamic, that's your projected texture.
Well, no. For anything that's dynamic, that's something for standard cascaded shadow mapping. This
So
is
you
just to
just
give
stick with
you
cascade. Okay.
this is just to give you like something beyond, something like a very low resolution shadow map that is for everything that's outside of the range of the cascaded shadow map.
Well, how big can I make the grid right now? Because I've noticed I can make it stupid big, and if I make it too big, I run into some issues where
You'll
I don't-
start
I
to
don't-
you'll
I don't know
start
how
to
to
see
describe
floating
it.
point imprecision once you get about
Yeah, that's what I thought it was.
about
What is this,
4
FP16 or FP32, or what are we at?
It uses 32-bit floats.
Okay.
But once you get about like 4 kilometers or beyond, I don't know, maybe 8 kilometers.
That's
away
why
from the
that's why I
origin-
said the 16 by 16 sort of thing, the 16:8 whatever thing. That's when I started running into some interesting issues.
How far were you from the origin?
I think it's like well over 8,000, 9,000 ish.
Yeah, you'll start to see
yeah.
some jittering in the vertices.
And you get some weird terrain issues and stuff, and I was like, okay, so this is not like that previous project I worked on. I do know one of the things I was thinking about implementing and that I haven't worked on yet is like a tiling scenario where you just load the next tile, but you kind of dump the last tile or the tile before, so that when you're flying over it, and then you have like when you're talking about like planet rendering, which is some of the stuff that I'm kind of playing with still, then you would just keep dumping it. And I'm trying to think what the term is for it, but that's what I'm trying to
Streaming?
do, and it does kind of work. Sorry, what is it?
Streaming, you mean?
Not streaming. There's another term for it, and it's basically where like you render this giant square, and then around that square, primarily you just render a couple other squares,
Yeah.
and then the last squares you create the LOD system to slowly dump that out of memory as you move in either direction, and you dump or whatever from this direction to this direction to this direction, depending on your perspective. But I did notice I ran into some floating point issues, and I was thinking it was
Well, I mean, in that case,
FP32.
if you just kept like recentering the camera, then everything would stay around you in the world, and you would stay near the origin, and everything would be fine.
Yeah, that's what I've been trying to do. But I was just more thinking like when I do lighting and stuff, what I'm starting to think that I'm gonna have to do if I were to do some renders that I'm thinking of doing with like Star Trek and stuff. I just need to create a cube area, and then from that cube I can have a sun possibly built into essentially a skybox, and have that give the initial light value, and then from there figure out like a local light value or something else. But that's kind of what I'm thinking of using fully what I want to do with Leadworks.
Well, I mean, in that case, you'll kind of have to implement your own like streaming setup, because that's like the kind of stuff that I'm saying, like, let's just not try to do that, because there's plenty of other engines that do that, and like that's
When
the
I
whole
told
source
you-
of their jittering, like why they have so much stuttering is because of those
By
things.
James is heading off, but yeah, when I told you that I was going to use the engine in unorthodox ways, these are the ways that I tend to use engines. I always try to push them to their boundaries. That answers a lot. I have some ideas now of what I can do from what you've described. I guess you have some updates that you're going to work on then there in the lighting aspect for more local scenarios. That's going to be interesting. I'll look forward to it, because I will play with it. I don't know what I'll publish. Honestly, I kind of just want to use it for renderings or get a general idea kind of thing out there.
No, it's like, I mean, very few people, everybody, if I ask, anybody like, hey, what if you could make worlds that were 10 times as big as World of Warcraft? Would you love that? What if you could make, something that was like 10 times the surface of the Earth with 100,000 different alien species? Everybody's going to say yes to that. But
well, you jump the gun there, because you say with 100,000 different alien species. But primarily what we see is stuff like I love the game Starfield. I think it's a very mid game, but it does a fantastic job. but everything is within a block cell if you've ever played with the creation kit. And what you see is there's only a limit to what you can add within that space, because otherwise you run out of the memory. And once you run out of memory, obviously you know what happens. You get scripting errors and so on and so on. So you have to break it down into sections for the engine and for the program to actually run. And I see that a lot in games where I think a lot of people think they want more than they actually want. And that's not what I don't think they know what they actually want when it comes to engine development.
It's like nobody realistically has the ability to actually take advantage of that. What people do realistically have the ability to do is something like, you know, the Amnesia series, you know, like the Dark Descent and you know, something like that, or something even like Crysis. People realistically do have the ability to create things like on that level. People do
Crysis. The thing about Crysis, I actually used to work with CryEngine 2, which was the one after Far Cry 3 for the original Crysis in 2007.
Mm-hmm.
I used to mod that substantially, and when you would make the paths and stuff, you would actually, in the editor, just tell it that, oh, this next bit is going to be rendered. But then the moment you do that, it dumps the last section. And you could actually like sequence break by going back to the previous loaded sector, which is kind of funny. Which
I thought
shouldn't
they
have
just
happened.
loaded everything all at once.
No, there was a lot of scripting stuff going on there where it would like it would
that's
go to the
CryEngine
next
2?
little bit. That was CryEngine 2, not CryEngine 3, but yeah, that was the one for the original Crysis. I used to do a lot of time of day modifications, script modifications. I restored a lot of the old beta content. I was one of the original guys on the Crysis beta team. Like, I was working on a lot of this stuff with CryEngine 2, and the way that it would do these things, you would sit there and go, oh, this is great, it works great. And then it just takes somebody like me, one player, you turn around and you walk backwards and you break the sequence of events. And then you can't move through a wall or something that gets triggered later. Because it's not rendered as one world, it's rendered as these little squares. And each of those squares has like height data and everything else calculated for. And there's a bunch of strange stuff with it.
But
I still say that was the best version of CryEngine.
So I'd say like my goal is to support game levels that are like as big as the biggest level in Crysis, which is about I think that's about 16, or what is that? Yeah, that's 4x4. I think that's 16 square kilometers, which is plenty big. I'm not interested in making tech demos that nobody's gonna make use of. Like, we can actually make like small to mid-size. By mid-size, I mean as big as the biggest
the
Crysis
largest
level.
If I remember from the largest Crysis level,
It's probably the first one.
yeah, that's what I'm thinking of, because that was the one I was talking about. I mean, it's way bigger than what you described, at least the absolute maximal limit. And actually, for a functional limit, it'd be closer to what you're describing. But like
I mean, it's
the absolute
it's a few
maximal
kilometers
limit,
wide, isn't it?
oh no, it's like I think it's in the billions of kilometers range. You could push it to the absolute limit, like the absolute limit. But you just have a flat plane at that point.
No,
in terms of like
I know the biggest height
functionality,
maps are 4096 by 4096.
yeah, it's 4096 by 4096 for those, and like
But that's
so
one-
like if you actually if you smoothed it out though, you could go I think it's like 60 billion kilometers if it's just completely smooth.
Yeah,
But then
you would
that's
have the
also
32-bit float pointing problems.
Yeah, and like so if you actually wanted a functional map, you'd be talking like in the 16 million to 20 million range, and even then you'd be limited to what you could actually display.
You'd be limited.
you
to
could
the
do,
same,
like-
you'd have the same exact limitations as Leadworks.
I think you could do essentially like 150 million kilometers squared, give or take,
No,
if you
no
really
way.
pushed it.
No.
I think you could with CryEngine 2, but are you okay with like 10 FPS or 5 FPS and then clipping through the level?
Do they continually recenter the player?
Yeah, because it basically tracks where
Well.
the player is from the perspective of the player. And then the problem is, as you're doing that, it has these little cells, essentially similar to like what most engines do. And then the player will just fall through the map. But like CryEngine 2 didn't place any sort of restrictions. You could make it this giant thing that just fills all your system's memory for no other reason than doing it. So I don't know. I guess that we're kind of off topic there, but yeah, it's like, I think it's like the meters per unit is just absurd with CryEngine 2. And then they dumped all of that and got rid of that for the remasters they did for the 360 and everything, because it's like, we really got to optimize this, guys.
Yeah.
Yeah, like the maximum size it says here for Crisis, the original Crisis, is a value of 476,736 square kilometers. Yeah, good luck loading that into your PC. Like I said,
so
I
they
remember
have something
dealing
in there
with
that
this.
accommodates the floating point precision, but doesn't.
It
but
doesn't
does
fix
not,
it. No.
But you would never like that. Your constraint would become your memory.
Yeah, and at that point, there'd be no reason to even go that large, because I mean, you're talking the distance between Earth to like, it's kind of like what Minecraft does, like the distance between Earth to Neptune or something.
Yeah, so
like,
so initially, like when I started this, those are the kind of things that I was very interested in. Until I finally realized that, okay, you have this enormous increase in complexity, combined with no increase in, like that will lead to no increase in revenue. It'll just lead to a ton of bugs, and all of that stuff becomes a burden on the developer, because they have to. I mean, you're never going to have all of that added complexity and have the same simplicity in the usability of the software. So it's like you have all this increased complexity, and the benefit just isn't really there.
yeah. Also, Andrew, I was talking about the thing with I didn't mean to say it that way. I meant the reference between like what Crisis or CryEngine allowed you to do versus what Minecraft did. I kind of missaid it there. But like with a lot of these like engines like CryEngine, they gave you all these different tools where they scale it to such a degree it's not very useful. And I don't think it'll ever be useful in classical rendering or where we are today. But yeah. It's interesting. I have, like I said, I have a lot of little projects I'm playing with Leadworks, and I'm interested in. I know you're pulling back up the slide, and I'm interested in these assets because I have some ideas for it.
Oh, I'm just looking at them. All right. All right. So figure out how to do 4 times upsampling with MSAA. I'll see you guys next week. I look forward to your answers. I know everyone's going to pitch in and figure it out.
Thanks, Josh.
Yeah, that was interesting though. Isn't that just so weird? I told you it was going to be an interesting, strange discussion today. Let's see what
I didn't
XRT
expect it to go as long as it is.
XRT is typing. Yeah, I need some water. All right, bye-bye.
He typed and said bye. I think we're good, Josh. I think we covered everything we need to today, because this is way more in depth.
All right, I'll see you guys later.